Today we will begin working with mixed and improper fractions. This is just the first part. Today we will answer the questions: what is an improper fraction? What is a mixed fraction? And how can I make an improper fraction into a mixed fraction? Well, in class you've already heard me read multiplication problems as 1/3 taken 7 times, which sounds strange until you remember that multiplication is repeated addition. I really am taking 1/3 7 times. And if you happen to have pattern blocks, I'm going to stop for a second and let you count out 7 1/3 pieces. And 1/3 assumes that the yellow hexagon is one whole. And if you're doing that, go ahead and pause the video for just a second. So now that you're done, you should have 7 1/3 pieces, or 7/3. Obviously that's more than one whole because 3/3 is one whole. So I'm going to give you just a minute. Take your 7 pieces and put them together to make wholes. And then check out what happens. What happens is you get 2 wholes and 1 left over. What you had before was an improper fraction. An improper fraction is one that has a numerator that's greater than the denominator, like in the fraction 7/3. On the other hand, a mixed fraction has a whole number and a fraction, like 2 and 1/3, which is what you're looking at your pieces. So take a second and stop the video, jot what's read into your notebook. You're going to need it. So let's try another. This time let's work with 1/2 pieces, which will be red trapezoids. Go ahead and count out 5 1/2 pieces. There we go, 5 halves, because there are 5 1/2 pieces. So I can write that. Alright, so here are our 5 halves. Alright, well take a second and put your halves together until you've got some wholes. So when I'm done, you can see I've got 2 wholes and a half. So we could say that 5 halves is equivalent to 2 1/2. Something to think about. Alright, let's try one more. Let's take 1/4 6 times. Go ahead and count out 6 1/4 pieces. And when you're done, what you'll have is 6/4. Okay, so there's my improper fraction, 6/4. What mixed fraction will I get out of this? Well, take just a second and build wholes, and we'll see what we've got when you're done. And you'll see what I have as a mixed fraction is 1 whole and half of another, or 1 1/2. The improper fraction 6/4 is equivalent to the mixed fraction 1 1/2. What if I don't have pattern blocks, or I just don't want to fool with them? Can this be done numerically? Well, of course it can. Let's try 12/9 and turn that into a mixed fraction. So the first step is to divide the numerator by the denominator. Why? Well, if you remember, division is repeated subtraction. And if 9 is a whole, I want to know how many wholes I can pull out of this. So first thing I'm going to do is divide my numerator, which is 12, by my denominator, which is 9. How many times does 9 go into 12? Well, it goes in 1 time. 1 times 9 is 9. Subtract. 3 is less than 9, so I'm definitely done with the division part. Step 2 is to ask yourself, is there a remainder? And in this case, there sure is. It's this 3 right here. So what do I do with it? Well, that's what's left. I have 1 whole. See this right here? I could take 9 out 1 time. That's my whole. I could take out 1 out. And then what's left is 3 little bits left out of how many? 9. So that becomes my whole number, and my remainder becomes the numerator, because that's what's left. And then what am I working in? I've always been working in 9s, so I'm going to keep working in 9s. 12/9 is equivalent to 1 3/9. Take a minute to stop the video and write down everything in blue, including what I hand wrote, into your notebook. Okay, keep that notebook open, because we're going to do the next one together. Let's work with 7, 6. First step is divide the numerator by the denominator. Go ahead and do that in your notebook. Alright, well, my numerator is 7 and my denominator is 6. I want to know how many 6's I can pull out of 7. 1. 1 times 6 is 6. Subtract, I get 1. So there's my whole number, 1. The next question to ask myself is there a remainder? Yep, it's right there. I have a remainder of 1, and I've been working in 6. I have 1 6 left over. So 7 6 is equivalent to 1 and 1/6. Let's try 2 more. I'll let you take a turn first, and then I'll show you what to do. So take 15/7 and turn that into a mixed number. Use your notebook. You've already got 2 examples and the directions there. All right, our first step is to take 15 and divide it by 7. Does 7 go into 1? Nope. Does it go into 15? It sure does. How many times? Twice. So 2 times 7 is 14. Subtract. I've got 1. 1 is less than 7, so I've finished. 2 is my whole number. Step 2 is to ask, is there a remainder? There is. Right here, it's 1. So that's how many are left over, and we're working in sevenths. 15/7 is equivalent to 2 and 1/7. All right, now take a shot at 13/2, and let's see what you can do. So let's take 13 and divide it by 2. Does 2 go into 1? It does not. Does 2 go into 13? It sure does. How many times? 6. 6 times 2 is 12. Subtract, you get 1. 1 is less than 2, so I'm done. Here's my whole number, 6. Do I have a remainder? Yes, it's 1. And what have I been working with? Halves. So I will stay in halves. And 13/2 is equivalent to 6 and 1/2. Now in class today, we watched a video by Mr. Dewey who talked about improper fractions and turning them to mixed fractions like we're doing. Since I can't link in the video, if you'd like to see it, pop over to YouTube, type in Mr. Dewey, you see how I've spelled it, and just put in fractions and you should be able to find the video. It's kind of cool. So what if we were working with a word problem? Let's walk it all the way through. We've got 9 kids and they each ate 1/2 of a personal pan pizza. How many pizzas did they eat altogether? Well, let's find out how many halves they ate altogether. There are 9 kids. I'm going to put that over 1 to show it's a whole number. And they each ate 1/2. That's a lot of wasted pizza. I hope they took it home. All right, 9 times 1 is 9. And 1 times 2 is 2. So we're dealing with 9 halves of a pizza. All right, so let's pop our 9 here because that's our numerator. And let's put our 2 here. That's our denominator. And I want to know how many times 2 will go into 9. How many times can I pull 2 out of 9? How many holes are there? So 2 goes into 9 4 times. 4 times 2 is 8. Subtract, I get 1. 1's less than 2, so I'm finished. My whole number is 4. Do I have a remainder? Yep, there it is, 1. And I've been working in halves. And you will see that 9/2 is equivalent to 4.5. Well, you try one. Here we go. If each kid in a group of 4 brings 1/3 of a dozen of eggs, how many dozens will they have? This one's kind of complicated, but let's take it one bit at a time. All right, your turn. Figure out how many dozens they're going to have. Well, let's start with figuring out how many thirds they've got. Go ahead and figure that out. Stop the video if you need to. So we have 4 kids who each brought 1/3 of a dozen of eggs. Well, 4 times 1 is 4, and 1 times 3 is 3. So we have 4/3 of a dozen. Okay. Oops. Let's take our 4 and divide it by 3. See if you can go ahead and finish up the fraction. Again, stop the video if you need to. Well, we're going to divide 3 into 4. It goes one time. 1 times 3 is 3. Subtract to get 1. So here's our whole number. We could take 3 out one time, leaving 1 left over out of 3. 4/3 is 1 1/3. So they had 1 1/3 dozen eggs. How many individual eggs will they have? Well, stop and ask yourself, what's 1/3 of a dozen? Okay, well, 1/3, let's take 12, because that's how many are in a dozen. I'm going to place it over 1 to show it's a whole number. Each kid brought 1/3. Okay, 12 times 1 is 12. 1 times 3 is 3. And I've already talked to you about this. Remember, division problems are represented in fractions. So let's take 12 and divide it by 3. And each kid brought 4 eggs. How about that? All right, so I think that leaves us done. It sure does. Today we answered the questions, what is an improper fraction? What is a mixed fraction? And how can I make an improper fraction into a mixed fraction? If you don't remember what an improper fraction is, that link is to another cool YouTube video called The Rapid Mathematician, and Bigger on the Topper. Again, if you pop over to YouTube and look that up, you'll find them. It's pretty awesome. Have an awesome, awesome day, guys.